Newton's first law of motion. An object in motion tends to stay in motion. An object at rest tends to stay at rest. Probably better yet, an object in motion tends to stay in motion in a straight line at a constant speed. An object at rest tends to stay at rest unless acted on by a net outside force. So what we're talking about here is that there are all sorts of forces acting on an object. Think about the computer that you're looking at right now. For most of you, it's just sitting there on the table. There's the weight acting down, force of gravity acting down. There's a normal force acting up, I assume, either from your lap or from a lap desk or from the table, something along those lines. And right now it's a balanced force. Now when we get to chapter 8 through 10, we'll talk about how that's just slightly off, but a lot of physics is like that. So right now we'll just assume it's balanced. The laptop's at rest, it's staying at rest. Now in order to get that to start accelerating, well, you'd have to push it. Well, pushing down's not going to do it because normal force will match it. If you push it off to the side, so if you start pushing it this way, then the computer, with enough force, if you overcome friction, will start to accelerate that way. And so the only thing that will stop it from being at rest is some net outside force. Now, at the same token, if I have an object moving, so let's say I have a car rolling towards me, well, it has a tendency to want to keep rolling towards me. The only thing that would stop it is going to be friction or some other force. So if I'm standing there doing my Superman routine, then I can push on the car to try to slow it down, but the car has a tendency to keep going. Now you're thinking, but the car's going to stop eventually. And even on a flat plane, if you go to Utah, where you've got this hundreds of miles of just flat and straight, then I keep have to apply gas because the car's going to stop if I take my foot off the gas pedal. Well, yes, but there's a net outside force. There's friction acting on the axle. There's actually the tire is rubbing against the road some, so you got some friction acting there. So there's other external forces that are causing this thing to sort of stop. And so objects in motion will stay in a straight line. Now the extension of this, which we get into in chapter 8, I believe, maybe 9, maybe 10, those chapters blur together, is if you're spinning something in a circle, think David and Goliath, think half dozen amusement park rides. If something's spinning in a circle, it's not traveling in a straight line. So there's got to be some net unbalanced force acting on it. Well, there is, but we'll get to that in a later chapter. Thanks.